So today we talk order of operations, which are basically the rules for general mathematical operations that you want to carry out in specific orders. The first thing we do is look to do anything that is grouped inside symbols, and when they refer to symbols, they're talking about parentheses or brackets. Next, you want to deal with all your powers, followed by multiplying and dividing, and we do that however we see it from left to right, followed by any additions or subtractions left once again as we see them from left to right. The common anagram or phrase that's used for order of operations is "please excuse my dear Aunt Sally," which refers to P for the parentheses, E for exponents, M for multiplication, D for division, and you do those from left to right, and then addition and subtraction. So one way to remember it. Let's just do some practice problems here. So we've got expressions, which are these numbers linked by additions, subtractions, and multiplications and divisions. And what we want to do is look to see if we have any parentheses in this first one. Clearly we don't, so what we're going to have to do is look for any exponents first. So here's my set of exponents. I will do this quantity first. So I have 12 divided by 3 times 5 minus 4 squared, which is 16. So the next thing we want to do is look to do any multiplications and divisions from left to right. So I notice these are all multiplications and divisions, but I do it from left to right. So I have 12 divided by 3, which is 4 times 5 minus 16. Now I have a multiplication that I need to do, 20 minus 16, and I end up with 4. And this is the kind of work I want to see you doing. I want to see the steps involved in doing these processes, not just doing it in your head. Take the paper, it's cheap. Next, I look at this term and I notice right off the bat I have a grouping. So I'll do that grouping first. So 5 plus 2 is 7. And now I notice I have multiplications and divisions, but I also have an exponent, which means I need to do that first. So this is 3 times 49 divided by 7. And in this case, we see we've got multiplications and divisions, but we do those from left to right. So I do 3 times 49 first, which puts me at 147. And then I need to divide that by 7. So if I do so, I get 21. Moving on to the next problem. Now in this case, it asks us to evaluate this expression. However, they say if I know that the A values are worth 5 and the B values are worth 2, so what we're going to do is every time we see an A, we're going to substitute a 5 in for that variable. And every time we see a B, we're going to substitute a 2 in. So I have 2/3, and when I have a bracket following that, that means multiplied by 8 times the quantity of 5 minus 2, and that's squared, plus 3b, which is a multiplication of 3 times 2. And we'll close the brackets off. So within these brackets now, I have an exponent, which I'll deal with first. And that gives me an 8 times, that's 3 quantities squared, and that's added to 3 times 2. Within these parentheses, I notice there's an exponent, so I have 8 times 9 plus 3 times 2. I'm going to do all multiplications and divisions as I see them from left to right. So within the parentheses, I notice I have 8 times 9, which is 72, added to, because I can't do any of my additions yet, 3 times 2 are 6. So in this case, I have a total of 2/3 times 78. Now, let's assume that you can't do this in your head, which I know you can, but let's use our calculator to help us do this. So here we have the calculator. What I want to do is multiply 2/3 by 78. Anytime I have a fraction, I'm going to put that entire fraction in parentheses. So that's 2 divided by 3, close my parentheses, multiply that by 78. Now, this may work out as a whole number or an integer or whatever, but I want to make sure that if it goes to a decimal, I don't want it in decimal form. I want to keep this in fraction form and preferably not a mixed number. So what I'm going to do is I'm going to hit my math button and say, notice here's this word frac. If I click the number 1 or hit enter right here, it will take, and whatever 2/3 times 78 is, it will put that into a improper fraction if 1 exists, or it will reduce it. So I hit enter, and notice it turns into actually an integer of 52. So everything reduced out. But if it wasn't a nice reduction, it would give me the reduced fraction. So just a little tip as to how to use that calculator. Let's go through the next example. Again, it's a substitution problem where I substitute a 5 in for every b and a 3 in for every x. So I have 5 squared minus 2 over 5 plus 3 squared. Now in this case, I'm going to look at my fractions and consider the numerator to be in a parentheses and the denominator to be in a parentheses. Therefore, within these parentheses, I have a squared, which gets me 25 minus 2, and then 5 plus 3 squared, or 9. 25 minus 2 ends up being 23, and 5 plus 9 is 14. And we're just going to leave that as is. We aren't going to convert to a fraction, or to a decimal, sorry. The only time we're going to actually use decimals is when a problem asks us to round to a specific decimal place. Otherwise, we'll keep everything in improper fraction form reduced. So let's look at a couple of word problems. It says each side of the Great Pyramid is a triangle. So the first thing I'm going to do is take and draw a triangle, because I know we're talking about triangles. The base of the triangles measured 230 meters, so the base is the bottom, and the height measured 187. The area of a triangle is half the product of the base times heights, which we already knew. We studied the areas already. So the area equals 1/2 the base times the height. We want to write an expression that represents the area of one side of the Great Pyramid. Well, that's this guy right here. And now we want to find the area, so now we're going to make our substitutions. We have 1/2 of the base, which is 230, times the height, which is 187. Now again, let's use our calculator to get this done. We'll go back and we'll say, all right, well, I'm going to take now and multiply 1/2 times 230 times 187. And I know this is going to reduce down to an integer because 1/2 times 230 will reduce evenly. But even so, let's just hit math, frac, and that will convert it to an improper fraction if necessary. And I end up with 21,505. And those are square meters. Let's not forget our units. The next problem is we have this person studying the growth of a population of fruit flies. She notices that the number in her experiment is 5 times as large after any 6-day period. And she observes 20 fruit flies on October the 1st. So here's October the 1st. and she sees 20. Now, she notices after 6 days, it's 5 times larger. So after 6, we get multiply by 5. And then after 6 more, we multiply by 5 again, etc., 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 until I get to the 31st. Well, 30 days have gone by, and in 30 days, there are 5 6-day periods. So if that's the case, then I'm multiplying by 5 times. In other words, total number of bacteria, is it bacteria? Or the total number of fruit flies is 20 times 5 raised to the 5th power. And we can do that on our calculator too. Let me show you how to grind that out. In this case, I'll take 20, multiply that, and I like putting it in parentheses, 5 raised to the 5th power. That's how I notate that. My power button is this, what we call a caret. I hit enter, and I get 62,500.